Hi there and welcome to the channel again, the Cambridge Advanced Level Mathematics channel. In this video, we want to discuss the idea of complex numbers. By the end of the lesson, we should be able to understand what a complex number is. But those of you who might have watched my previous video, I was dealing with quadratic equations and we used the quadratic formula to solve quadratic equations. But in that video, we were choosing some nice quadratic equations with real roots. I have deliberately chosen these equations on the board here such that they do not have real roots, and this will lead us to the idea of complex numbers. So let's start with number one. Equation number one says x squared plus 2x plus 5 is equal to 0. Now we know that in this equation, our a is 1, our b is 2, our c is 5. So if we were to use the quadratic formula, this gives us x is equal to minus 2, because b is 2, plus or minus the square root of b squared, which is 2 times 2, it's 4, minus 4 multiplied by a is 1, and our c is 5. This is all under the square root sign, and everything here is to be divided by 2a, which is 2 times 1, which is just 2. So that is the quadratic formula. Let's simplify what is inside the square root sign. We have minus x is equal to minus 2 plus or minus 4 times 1 is 4 times 5 is 20. So that gives you 4 minus 20 under the square root sign, of course divided by 2 here. Now 4 minus 20 is minus 16. So we have minus 2 plus or minus the square root of minus 16 all divided by 2. The square root of minus 16 can also be written as the square root of 16 multiplied by the square root of minus 1, because minus 16 is 16 times minus 1. So this can be equal to minus 2 plus or minus the square root of 16 multiplied by the square root of minus 1, all divided by 2. Well, square root of 16 is 4. So we can write this as x is equal to minus 2 plus or minus square root of 16 is 4. So we put a 4 here multiplied by the square root of minus 1. All this over 2. Of course, we can cancel with the 2. This gives us there it's 1, it's minus 1, plus or minus 4 divided by 2, it's 2 multiplied by square root of minus 1. Here is our problem. There is no real number which when you square it, it gives you minus 1. So this thing which is inside the square root sign, which is the square root of minus 1, is given a special name. It is not a real number, it is an imaginary number, and that imaginary number is denoted by the letter I. So this part here, which is the square root of minus 1, is written as I. So our solution is now minus 1 plus 2i, which is this I, or minus 1 plus minus 1 minus 2i. Remember, it's plus or minus. So we have two roots here, and they are minus 1 plus 2i or minus 1 minus 2i. This part here is an imaginary number, but this whole number here, which is a combination, the sum or difference of a real number and an imaginary number, which is this part here, is what is called a complex number. It's a complex number. This is also a complex number. Look at it carefully. You can see that the difference between this number, this complex number, and that complex number is that this one is -1 plus 2i. This one is -1 minus 2i. These two numbers are said to be complex conjugates of each other. So let me write it here. These two here, they are complex conjugates of each other. And it always happens that once a quadratic equation has got one root which is complex, such as in this case, then the other root will have to be the complex conjugate of this one. So they always come in pairs. Okay? So, all right. Now let's go on to equation number 2. Now that we have invented a new number system, we are not going to panic when we see something happening here. Let's see if this takes place. So number 2 says x squared plus 4 is equal to 0. We don't need to use the quadratic formula here. All we need to do here is take 4 to that side. Then we have, this implies x is equal to, x squared, is equal to -4. But of course, -4 is equal to -4, multiplied by -1. Okay. Taking the square root of both sides, x then is equal to square root of 4 multiplied by square root of -1, which is equal to 2. It has to be plus or minus 2 square root of -1. Now that we have invented complex numbers, we don't panic when we see that. We can now write this as 2i, plus or minus 2i. So this quadratic equation has two roots and both of them are complex. In fact, as we have noted previously, these are complex conjugates of each other. They are complex numbers because the real part is 0. So it's just 0 plus or minus 2i. So this also is a complex number. Let's proceed to number 3. Number 3 says 2x squared plus 3x plus 5 is equal to 0. Let's use the quadratic formula here. Our a is 2, our b is 3, our c is 5. So x is equal to -3, which is b, plus or minus the square root of b squared, which is 9, 3 times 3, minus 4 multiplied by a is 2, c is 5. And of course, all this is under the square root sign. And this is to be divided by 2a, which is 2 times 2, which is 4. Let's simplify what is inside the square root sign there. That gives us a 9 minus 4 times 2. 4 times 2 is 8. 8 times 5 is 40. So this is 9 minus 40, which is minus 31. So we can write here our x is equal to -3 plus or minus the root of minus 31. This over 4. Let me check my calculations. 4 times 2, 8 times 5, 40 minus 9, 31. We are fine. This we can also write as minus 3 plus or minus the root of 31 multiplied by the root of minus 1, all this over 4. Okay, so that gives us minus 3 plus or minus the root of 31i, our root of minus 1. All this, of course, divided by 4. We can write this as, so the two roots are minus 3 over 4 here, plus root of 31i over 4, or minus 3 minus, let's check if this one will write correctly, minus 3 minus the root of 31i, this over 4, and again that over 4. Once again, look at the two roots. They are complex conjugates of each other. The other one is minus 3 over 4 plus 31, square root of 31 over 4i. The other one is minus 3 over 4 minus the root of 31 over 4i. So those are the roots of the complex of the quadratic equation. The other thing that we need to know about our imaginary number I is that I squared is always equal to minus 1. I squared is equal to minus 1. So I cubed would, let me just clear the board very quickly. Let's clear here. I cubed, oh, look at that, I'm writing a T. So I cubed is equal to I squared. Why am I putting a T? Oh my goodness. I squared multiplied by I, which is equal to, this is minus 1, so this will be equal to minus I. I to the power 4 will be, I to the power 4 is equal to I squared multiplied by I squared. But we saw that I squared is minus 1, and this I squared is also minus 1. So this becomes minus 1 multiplied by minus 1, which is equal to plus 1, and so on. So whenever you are given powers of I, remember to write it in this form, and remember always that whenever I is squared, the result is minus 1. Then from there, you can evaluate the power of I. In our next video, we are going to then discuss addition and subtraction of complex numbers, multiplication of complex numbers, and division of complex numbers. That should do for the next video. And then in our third video, we are going to discuss the magnitude of a complex number, or the modulus, and the argument of a complex number. Till we see you then,